For lesson 3.3, we're going to talk about modifying what we put in or what we get out of a linear function and see what it does to its graph. So if we consider the graph y equals negative 4x and it's graphed here, notice that our slope is down 4 over 1 because that is our slope here, and our y-intercept is a 0 because there's nothing there. So if we've plotted that function, they'll ask us to compare it to the graph of negative 4x minus 3. Well, we can see in the equation that this end value, the y-intercept, has changed. Same thing with the plus 1.5. If we were to graph these, we would have a parallel line with the same slope of negative 4x, but now it's crossing here at negative 3. Or if we were to do the same thing with our other graph, we would start at 1.5 and see that our slope would still be a negative 4. They'd all run right up against each other, but our y-intercepts change. So if we talk about changing this end value outside of our function, we can see that it shifts our y-intercept. The first one shifted it down 3, the second one shifted it up 1.5. We call this a vertical translation. Vertical means up and down, and translation means like a movement. So if you ever change, if you will, the b or y-intercept value on a function, it will take the entire graph and move it up or down, keeping the same slope. Now if we change a value inside the parentheses, so notice how we have 2x minus 4. What if they were to put in, instead of just x, they put in an x plus 5? So they replace just a simple x with an x plus 5. If we look at the graph over here, when I look at my second graph, my g of x graph, I will know that when I graphed this equation using some coordinates, it gave me the green one. I now see that I have my x-intercept moved over, and it is moved over 5 units. So since it moved back to the left 5, we can see that anytime we change our input, whatever number we multiply in by a plus or minus, it will do a horizontal translation. So horizontally, we'll move it left and right. Now notice though, our purple line was the original one graphed over here. This was our original y equals 2x minus 4. When I graphed that, that was the purple line. Now it moved to the left 5. So when you see a plus 5, you probably don't think of it as moving left, because that would be in the negative direction. It is somewhat of an opposite transformation. So we're going to have a horizontal translation in the opposite direction. One thing you could check is I did try distributing that 2 through and got 2x plus 10 and subtracted 4. And when I graphed 2x minus 6, it was that same green line. So whenever you change or add or subtract a number inside your parentheses with your input, it will translate the graph horizontally in the opposite direction of what sign you put. Again, a transformation is changing the graph. A translation is a shift, up, down, left, right. So in summary, on this page here, our horizontal translation is the one that changes our input when we add or subtract to our input. Our vertical translation is when we add or subtract to our final answer, our output. We should note that both of these transformations had to do with adding and subtracting. Now we're going to talk about multiplying. What if we would multiply the output of a linear function? That is, we put in a number for x, do our math that we're given, and then multiply it by a number. Well, over here graphed, I have the graph of 4 times my output. So when I input a 1, I used to get a 0. Or when I input 0 here, I used to get 1. Now when I input 0, I still would get 1 here, but then I would multiply by 4. That takes all of my outputs times 4. My outputs will be multiplied by that factor. This ends up stretching our graph vertically. It will stretch it if your number is greater than 1. So because I multiplied by a 4 here, my y values got 4 times as tall. Think about here, my height was 1, and it went to 4. Here my height was 2 and it went to 8. 2 times 4 makes 8. I was multiplied my outputs by that number. Had the number on the outside been a fraction, my graph would have been multiplied by a fraction, which actually would have made it shorter or compressed. So now we're going to talk about if we would multiply just the value we're putting into our equation by a number. So in the past, in the last example, we input a number for x, do our original equation work or operations, and then multiply our output by 4. That was a vertical stretch. Now we're going to input a number but multiply it by 3 first and then add 1. So for example, if I were to put in the number 6, on my original equation, 6 plus 1 gave me 7. So I have that coordinate here. But now I want to keep that y value of 7. I want my height to be 7 still. In order to keep that height of 7, I want 3 times some number to be 7. Well, I know this needs to become a 6 in this parenthesis, so my number that I should plug in for x is 2. Therefore, if I look at the graph on my new green equation, I would put the 2 in to get the same height of 7. So this one's a little tricky because in general, it's way easier to think of the previous example where the graph looks as though it's vertically stretching up taller. But right now we're messing with our input. And so we're looking at what's happening to the input. It used to be 6 and now it's 2. In order to keep the same y value, I want y to be 7 just like it was on my original, and I'm comparing those two y values on these lines. The difference is I was able to plug in 6 on the first one. I actually had to plug in less than 6 in this other example because I wanted to take a number times 3 to get that 6. 6, if I took a third of that, 6 times a third makes 2. In short, we call this multiplying your input by a linear function a horizontal stretch or compression. Again, it's hard not to look vertically, but what we're saying is that when you multiply the input by a value and you're trying to look for what their outputs will match, you need to put in this case, a third of the number so the outputs will match. And it just so happens that we call this a compress or stretch horizontally when you affect the input because you're changing the x value. In our example, our multiplier looked to be 3, but our new green graph is actually compressed by a factor of 1/3. So, if you would ever have a function in which you were asked to multiply by 5, your input by 5, you would actually be having a horizontal compression by 1/5. It's always the reciprocal, if you will. So if someone wanted to do a multiplier of your input by a half, no matter what this outside number is, it doesn't matter. This would actually be a horizontal stretch times 2. So you can remember that if we're multiplying our inputs, putting just the multiplier by your x value first, that's a horizontal stretch or compression. But if you're multiplying your outputs by a value, that will be a vertical stretch or compression.